Hello, young chemists. Let me ask you something. Have you ever looked at a bottle of vinegar and wondered what's inside chemically? Or picked up a tube of ointment containing magnesium hydroxide and thought, what does that mean? That, my friends, is the magic of chemical formulae. Chemical formulae represent the composition of a compound using element symbols and numbers. For example, water is written as H2O, which means each molecule contains two atoms of hydrogen and one atom of oxygen. All chemical formulae reflect electrically neutral compounds, which means the total positive and negative charges must cancel out. And that's where valency comes in. Valency is the combining capacity of an element. Sodium, for instance, has a valency of 1. Oxygen has a valency of 2. So, to balance them, we need two sodium ions for one oxide ion, and the correct formula becomes Na2O, sodium oxide. Cations, those are positively charged ions like Na plus or Ca2 plus, always come first. Anions, negatively charged ions like Cl minus or Co3 minus, come second. So, in summary, a chemical formula is like a mini equation that reflects both the ratio and the balance of charges in a compound. Now, how do we actually write these formulas? Here's a simple trick called the left to right method, also known as the crisscross rule. Let's start with potassium and chlorine. Potassium has a valency of 1, so it forms the ion K+. Chlorine has a valency of 1 as well, forming Cl-. Since the charges are equal and opposite, they cancel directly. So the formula becomes KCl, potassium chloride. Let's now look at calcium and chlorine. Calcium has a valency of 2, written as Ca2+. Chlorine has a valency of 1, or Cl-. Now we apply the crisscross method, bring down the valency of calcium to chlorine and vice versa. This gives us the formula CaCl2, calcium chloride. One more, calcium and nitrate. Calcium is Ca2+. Nitrate is a polyatomic ion, no 3-. Using the crisscross rule, we get Ca open bracket NO3 close bracket 2, calcium nitrate. The brackets show that we need to nitrate ions. So always remember, balance the charges using the crisscross method and use brackets for groups like nitrate or sulfate if needed. Let's now explore common potassium compounds. Potassium has a valency of 1 and forms the K+ ion. When potassium combines with chlorine, it forms KCl, potassium chloride. With bromine, it's KBr, potassium bromide. With iodine, it's Ki, potassium iodide. Potassium with hydroxide becomes KOH, potassium hydroxide. With nitrate, it forms KNO3, potassium nitrate. And with nitrite, it is KNO2, potassium nitrite. Here's a slightly more complex one. Potassium carbonate is written as K2CO3 because carbonate is CO3 and potassium is K+, so two potassium ions are needed. Another example, potassium dichromate is written as K2Cr2O7, that's two K+ ions balancing one dichromate ion. Each of these compounds has its own use, from fertilizers to fireworks to industrial oxidizing agents. Keep these formulas in your memory toolbox. Now let's talk about sodium, the Na+ ion. It's everywhere, from salt shakers to soap factories. Sodium chloride is NaCl, table salt, the most familiar one. Sodium hydroxide is NaOH, also called caustic soda, used in making soap. Sodium carbonate is Na2CO3, known as washing soda. Sodium bicarbonate is Na8CO3, that's baking soda. Sodium nitrate is NaNO3, used in fertilizers and explosives. Sodium nitrite is NaNO2, used in preserving meats. Another one, sodium sulfate is Na2SO4, where SO4 is sulfate carrying a charge of 2 minus. So, we need to Na plus ions to balance it. And sodium aluminate is NaLO2, used in water purification. Sodium compounds are simple but powerful, used in industries, homes, and even hospitals. Now, let's move to alkaline earth metals, calcium and magnesium. Calcium has a valency of 2 and forms Ca2+. Calcium chloride is CaCl2, used in medical fluids. Calcium hydroxide is Ca open bracket OH close bracket 2, that's slaked lime, used in whitewashing. Calcium carbonate is CaCO3, that's chalk and limestone. Calcium nitrate is Ca open bracket NO3 close bracket 2. Calcium bisulfite is Ca open bracket HSO3 close bracket 2, used in bleaching. Magnesium also has a valency of 2, it forms Mg2+. Magnesium chloride is MgCl2. Magnesium hydroxide is Mg open bracket OH close bracket 2, known as milk of magnesia. Magnesium nitrate is Mg open bracket NO3 close bracket 2. And magnesium oxide is simply NgO. Each of these compounds has specific roles from treating acidity to forming building materials. Now let's look at zinc. It forms Zn2 plus ions. Zinc chloride is ZnCl2, used in antiseptic creams. Zinc hydroxide is Zn open bracket OH close bracket 2. Zinc nitrate is Zn open bracket NO3 close bracket 2. Zinc sulfate is ZnSO4. Zinc carbonate is ZnCO3. And here's a complex one, tetramine zinc sulfate. It's written as open bracket Zn open bracket NH3 close bracket 4 close bracket SO4. This means one zinc ion surrounded by 4 ammonia molecules forming a complex ion Zn open bracket NH3 close bracket 4 with a charge of 2 plus balanced by one sulfate ion SO4 with a charge of 2 minus. This is an example of a coordination compound where bonding is more than just simple ionic or covalent sharing. It involves donation of lone pairs. Alright, let's revise everything we've learned about writing chemical formulas. We began by understanding how a formula is a representation of atoms and their combining capacity or valency. Then, using the left to right method or crisscross method, we learned how to balance the charges between cations and anions. We explored how elements like potassium, sodium, calcium, magnesium, and zinc form compounds and how to spell those formulas correctly. And we've tied every formula to a real-world application, from fertilizers to fire extinguishers to medicines. Each of these compounds has specific roles, from treating acidity to forming building materials.